Hey everyone, are you looking to implement your own Google-like search box where users can enter something into it and relevant results will be suggested? Well, you found the right video then, because I'm going to show you how to do that with just Nextjs, Nodejs, Material UI, and MongoDB. So without further ado, let's get started. So the first thing that you're going to need to do is go to mongodb.com and then hit sign in. And if you've got an account, go ahead and log in. Otherwise, go ahead and sign up. So after logging in, you should be on a dashboard like this. If you're not, go ahead and click this leaf in the top left corner and then go ahead and create a new project. So for the project name, I'm going to call it Locations because I'm trying to make a Google Maps clone. Hit next. Add any members that you want here. I'm going to just create a new project. When you get to this screen, go ahead and build a database. And we're going to go with a shared database and create that. Here I'm going to choose AWS, but go ahead and choose whatever you want. And then I'm going to name this something besides this, probably location. And then create the cluster. So when you get to this page, create a username and password. And then create user. Okay, that's cool. Local environment, and then here input 0.0.0.0/0. That'll just whitelist any IP. Finish and close. Go to database. There you go, your cluster is getting set up. So once your cluster is set up, click connect. And then connect using MongoDB Compass. And if you have Compass, click I have Compass up here, then click your version. I have 1.12 or later. Copy this. But if you don't, go to this button and download, then follow the instructions. And then head over to MongoDB Compass. So once you've opened MongoDB Compass, you should see something like this. Click on New Connection and input your connection string into this box. Then change out for the password with the one that you just created, and then click Connect. That'll bring you to this screen. Now let's create a database. For the database name, I'm going to call it Location. And for the collection name, I'm going to call it Cities. Now create database. Go into Location. Go into Cities and add data. And I'm going to import a JSON file, which you can find linked in the description. It'll be to my GitHub. Select file. JSON import. And this is going to take a while. Now that we're finally done importing, we can start on our backend. So create a folder anywhere you want and navigate to it using the command line or the terminal, and then do either yarn init -y or npm init -y. Then once you've done that, go ahead and open it in whatever text editor you prefer. So now that we've got VS Code open, I'm actually going to create another folder called server, and this is just to make our folder structure cleaner for in the future. And then I'm going to create a file in server called index.js. Now that that's been done, open the terminal using Control-tilde and add some dependencies. Make sure to cd into server, and then I'm going to do yarn add, or you can use npm install, then MongoDB, cores, express, and .env. With those dependencies installed, let's create a .env file in the server folder. And we'll come back to that. But let's build out the skeleton for the index.js file. So go ahead and import .env. And then configure that. then require express, require cores, and finally import Mongo client. Then create an Express app. Now head back to MongoDB Compass, click up here and disconnect, and then copy this string. Now that you've got that copied, head to the .env file and type in Mongo connection equals, and then paste in that connection string. So mine has a lot of unnecessary fluff at the end of the string, so I'm gonna go ahead and delete that, and you can delete up to this question mark. Next we can head back to index.js, and I'm going to close that, and then we create a client. process.env.mongo_connection. Then we're going to connect that. And console.log it that we're connected. Now we're going to add some middleware. And then I'm going to listen on port 4000. And I'm going to create a basic route just to display that it's working. Go let result equals await client.db location dot collection cities dot find one with a country code of AE. With that all done, let's run node index and head over to localhost port 4000. So here is the result of going to localhost port 4000. Also, one thing to note is make sure that you're in the server directory whenever running node index. So if you ran into any problems, just make sure you're doing that. So now that we know that we can connect to our database and our node server is working, let's go ahead and create some search indexes in MongoDB Atlas. Alright, so head back to this page and click Browse Collections. Then click on Search. Then create Search Index. And we're going to go with JSON Editor. Let's go ahead and pick cities. That's our only one. And we're going to call this one Autocomplete. So I'm going to show you two ways to do it. So the first way is the autocomplete way, and it sacrifices accuracy for efficiency. And the second way is a text search, which tends to be less efficient, but I've found it to be more correct. So I'm just going to go ahead and type in the configuration method and then explain it to you afterwards. So I'm going to set dynamic to false, fields to search name, and then full diacritics, false, max grams, it's going to be 7, min grams, it's going to be 3, tokenization, it's going to be edge gram, and type is going to be autocomplete. Next we're going to put city. And I'm just going to copy and paste this. Click next, and then create search index. To explain why I use search name, this includes the city name and the country and the state if they're in the US. So I figured that that's probably what the user would search for, and then I also use city because users are going to search for the city. And both of those are in this schema right here. So if you're wondering why I use search name and city, that's why. Now if you're wondering why I use that specific index, go ahead and check out the autocomplete documentation. And I just went over to right here, and this is what they recommend. Now that our autocomplete index is done, let's go ahead and create the default index. This is the one that I prefer to use, and I'll show you why. So let's go ahead and JSON editor, same as last time. Pick the cities. So I'm just going to copy and paste it for this one. We're going to set dynamic to false, fields to city, and within that, analyzer is leucine.standard, and type is string. Search name, analyzer will be leucine.standard, and type will be string. And then create search index. So now that we've got our search indexes made, let's go ahead and finish off the endpoints for our REST API. So I'm going to give the autocomplete index an endpoint of search1, and this is what the skeleton of that is going to look like. And then for the second index, I'm going to give that the endpoint of search2. So for both endpoints, we're expecting the user to be searching for city. So we're going to go ahead and get that search endpoint with rec.query.city in both instances. And if there is no query, we're going to send them an empty array. Next, we'll create a variable called results. Then we'll create an if statement for the query. If the query includes a comma or a space, then we'll assume that it includes the states or the country. So we'll do that for both endpoints. In the first if statement, we're going to go ahead and make a call to our database. Wait client.db of location, collection being cities, aggregate. This is search. It's telling us which index, autocomplete, so that's our first option. The query is going to be whatever the user gives us. And search name. Search name is a field in the documents that are within the cities database. Fuzzy indicates that users can be one letter off. And then token order is going to be sequential. And then project stands for what we want to show the user. And then we're going to create a limit of 10. And then turn that into an array. And then we're going to send the results to the user. And we're going to follow the same structure when it's just the city. So let me paste that in. aggregate, return the results there, except this time we're going to be querying the path of city. So this is the field in documents. And then same thing here for project, and the limit is the same. Now let's start the server and make sure it works. So I'm going to type in localhost port 4000 / search 1 * city equals Atlanta and search, and we have various different autocomplete options here, and as you can see, well, let me zoom in, make sure. So as you can see, all of these have a score of 1 even if they aren't necessarily correct. Like Atlantis, I can see how that could get a score of 1, but why isn't North Atlanta higher rated? So that's one of the reasons why I don't personally like this method. But to show you that it works with states, I'm going to type in Chicago, Illinois. And we get the same type of thing here. Now I'm going to show you the superior way to search. So it starts off very similar. You await client.db of location, collection being cities, aggregate, search, but this is the difference. And we're also, the index is going to be default. You don't necessarily have to specify this. I believe this is what it is by default, but here's where it's different. So compound, within the must array, we have text. The query is going to be the city, the path being search name, and then here's the fuzzy. Then we're going to limit of 10, and then project all the same. We're going to turn that into an array, and then we're going to send that to the user. And then outside of that if statement, it will be the same thing, well, almost the same thing, except the path here is going to be city instead of search name. Now let's restart our server. And I'm going to type in localhost port 4000 search 2 with city equal to Atlanta. And let's see the difference. So as you can see, there's various scores, and Atlanta is the name of these cities. And as you go down, they start to descend. And then let's do Chicago, Illinois as well. And what do you know? We'll get Chicago right there, top hit. Now to be fair, I'm using the search index as an autocomplete in the second option, but as you saw with the first option, when you have over 1 million documents in your database and you have many documents that overlap or are very similar, I think that's the way to go, at least if accuracy is of any concern. But I do think the autocomplete would be good if I had less documents in my database and if I had another way to impact the scoring. Now let's go ahead and create the front end. So go ahead and create a folder called client, and then open up your terminal. And I'm going to close down this. Then navigate to client, and then input yarn create next-app period. With our next app installed, let's go ahead and install the Material UI dependencies and Axios. So that's going to be at MUI/material, at emotion/react, at emotion/styled, and Axios. So now that all of our dependencies are installed, let's head over to the client folder then go into pages and index.js. And once you get here, go ahead and delete everything in the main element. Delete everything in the footer. Now let's add our imports. We can get rid of image. And then import React and use state from React. Import text field from @mui/material/text field. Import autocomplete from @mui/material/autocomplete, and import Axios from Axios. Now we're going to create two functions. The first one is going to be called getCities1. It's going to be an asynchronous function and take a string. We're going to wrap it in try-catch block, and we're just going to console.error the error. And then we're going to replace any commas in the string with an empty string and assign that to a variable called searchable city. Then we're going to let the URL be the search1 endpoint, and we're going to have the query be city. And then we're going to get the response from that, the data response in particular, and we're going to return that. Now we'll create another function called getCities2. I'm just going to copy and paste this. And we just need to change the name to 2, getCities2, and then change this instead of search1 to search2. Now within the home function, let's create two states. The first one is going to be options1, and we're going to initialize it as an empty array. And the second one is going to be options2, and that's going to be an empty array as well. Now let's add the autocomplete components to the page. So I'm going to wrap them in a div with a top margin of 50. The first component is going to be autocomplete with a parameter of free solo. Then add these filter options. For onChange, this is when a user clicks on a suggested option, so we're just going to log that event. And for options, we're going to use our option1 state. If there is an array, we're going to map the full name of that object. Otherwise, it's going to be an empty array. And then for render input, we need a text field, and then pass in those parameters. Label is going to be search1. And onChange, we need to create an onChange1 function. So let's create onChange1. It's going to be an asynchronous function that takes an event. If e.target.value is not equal to null, we're going to let data equal the data from getCities1, and we're going to pass in that target value. And then we're going to set options1 to that data. So that's the data that's getting returned from our backend. Now let's make sure it's working, so open up the terminal, change the directory to server, and then run node index. Then open up a new window in the terminal, change directory to client, run yarn dev, and let's head over to localhost port 3000. So now that we're on localhost port 3000, let's check it out. I'm going to type in Atlanta. And here are the results. And just as a reminder, this is hitting the endpoint for our autocomplete index. And let's type in Chicago. And pretty close. It also fuzzy searches, so let's try something like San Francisco. And there you go, you see it's giving relevant results. And if you click on one of these, it will show you the event in the console. So now let's create the second autocomplete box for our second endpoint. So I'm just going to copy this and then paste it. We're going to change the options to say options2. And then we're going to change this onChange to onChange2. And we're going to copy this, paste that, and then where it says await getCities1, we're going to change that to getCities2. And then here we're going to say set options to. And for the label down below, let's change that from search 1 to search 2. And also change onChange1 up here to onChange2. Now let's test it out. I'm going to type in Atlanta here. And there you go. And let's type in Chicago. First result, San Francisco. CA. And then let's compare it to the top one. So let's try London. London, Canada, England. So all hit with London compared to the first one. Yeah, it's night and day. So next, I'm going to show you how you can handle one of these options being clicked. And we're just going to display it on the screen. So because we've been logging the event to the console, we can actually see the field that is going to be holding this value. So that's going to be in target and inner text. So let's create a new state. We'll just call it value. And it's going to be initialized as an empty string. And then for the onChange, on Autocomplete, we can just set the value there. So we'll go set value e.target.inner text. And we can copy and paste this for below. And then let's create a heading that displays value. So now let's test it out. I'm going to do San Francisco, Argentina. There you go. And test this one out. Or actually, let's do this. And Atlanta. So that's it. I hope this helped. If you want to look at the code, the link will be in the description, and the link for the dataset will also be in the description. Thank you for watching.